Hi, I'm Phil, and today we're going to have a look at my final project on a pedestrian controlled traffic signals. It's going to use a smart camera to count the number of pedestrians that are waiting at traffic lights and give the pedestrians, if there are more of them, more priority at the traffic signals. So here's the project. And we'll close all the branches of our project mind map. We'll have a look at what it looks like on the desktop. So we've got a countdown timer, pedestrians waiting, and two aspects of our traffic lights. So we've got one for vehicles and the other one for pedestrians. And you can see the overview on the top. It's all been driven by an ESP32 computer, which is in a package, a Xiao computer package. And we're connecting a Raspberry Pi camera to the Xiao Vision AI version 2, which you can see here, and that's connected to a Grove I2C hub. And we also have a Grove pulse width modulation with 16 channels, and that also is connected via the I2C hub. So let's have a look at what the objectives are. What we want to do is count the number of people waiting at the traffic signals. And we're going to do that with a bit of AI, and we'll be using distributed software, both in the Grove Vision, and also we'll have a program running on the Xiao computer. So we're going to give the pedestrians more time to cross the roads if there are more of them, and we'll also reduce the time that they have to wait at the traffic signals. And that'll encourage more of them to come together. If they're seeing that there's a few people waiting at the traffic lights, they can hurry along, and that will reduce the time that they have to wait. Now, the prerequisite for this project, we've looked at previously. We're going to use an online tool from Seed Studio called SenseCraft. And the format for our Grove Vision 2 camera has already been prepared, and we're using a pre-trained model, even though that we'll be using images in a different context. So we've already done that, and the previous video has shown how that is done. For the design, we're using the Grove pulse width modulation channel, 16 channels, and that'll switch on the traffic signals. For the camera, we're using a smart camera, and that's also going to count pedestrians waiting. And for hardware, let's have a look at all the hardware that we're using. So we'll go right to the top, and you can see that our Xiao computer, very low cost and quite powerful. So for under $5 US, the only thing is you have to solder that together if you want to put it into a base for other Grove modules. Okay, so we're using the Grove Vision kit, the AI kit, and it consists of, in the middle there, we've got our Grove Vision AI version 2 with the Xiao and a Raspberry Pi camera with a ribbon that connects the camera to the Grove Vision AI module. We're using a Grove base for Xiao, and that allows us to connect additional Grove modules. And you can see one of them there is the Grove 4-digit display, and we're going to use that as the pedestrian countdown timer. And we use it using Grove cables and to connect to our traffic lights. And there we're using the Kitronic stop bit, and that's connected to the pulse width modulation unit. And we're using a Raspberry Pi camera, but in addition, we're protecting that and connecting it to Lego components with the Adafruit camera case. So you can see all the connections here. We might actually go across and have a look at those now. So for our people, we're going to use these images. We're hoping that our Grove AI module will pick them up. And for the hardware, let's have a look at the hardware. We'll put that on slideshow. Okay, so for the hardware, we start off with the Xiao ESP32-C3. That's connected to a Windows PC. And the Xiao is also sitting on top of a Grove base so that we can connect more components. One of those is the Grove I2C hub, and that allows us to use more than just the one I2C peripheral. So one of those is the 16-channel pulse width modulation unit, and that's connected to our traffic signals. And all of the other wires for our traffic signals are shown here, and we have a second unit. So just like the first set of traffic signals, we add an additional set, and we've got now 16 we've got 6 lights to control with our Grove pulse width modulation unit. And the other unit that we add to our Grove hub is the Grove Vision AI. So right on top here, you can see the Raspberry Pi camera connected by a ribbon cable to the Grove Vision AI, and that's connected to the Grove I2C hub. And that software is controlled by the Xiao ESP computer. So returning to our mind map, we'll have a look at the software. And we've already spoken about the firmware that goes into our Grove Vision AI module. The other piece of the software that's necessary is the code that goes into the Xiao computer. And if we actually look at that on the Arduino IDE, we might just open that up now. So here's our Arduino IDE with the PEDCAM5 software. And you can see I'm setting up the variables. Since I've got 2 posts, I've got 6 traffic signals, and I've got names for them all from red, yellow, green, 1 and 2. And I'm setting up the maximum times for a traffic cycle, which has got a number of phases to it. And right at the start on setup, I'm initializing both the Grove Vision and also the 4-digit display. So you can see that's been set up here. Then I've got a couple of modules. The pedestrian display update is pushing the pedestrian time that's left over to various digits on the 4-digit display. And I've got another routine that checks the AI box and is using a parameter from the AI method to assign the number of pedestrians. So PED number is based on the number of boxes that are available. And you can see that just here. And the rest of it is only for debugging. And in the loop area, I'm calling the check AI box and then setting up the various phases of the traffic cycle. And you can see that I'm setting up less time for the green phase for cars if there are more pedestrians. And also I'm here where the green 2 comes on for pedestrians. I'm giving them also a countdown time and giving them more time if there's more pedestrians. Okay, so we'll return to our mind map. And that's the software, all coded in the Arduino IDE for the Xiao computer. So the results, I'm printing the results onto a serial monitor, and you can see in this case here, I've got 15 pedestrians, and I've got 3 pedestrians that have been counted, and the boxes for those and where they're located is also reported. Okay, so all of the objectives have been achieved, and we've given more time for pedestrians to cross if there are more of them, and there's less waiting time. Okay, so plenty of interesting things to extend it. I could add push buttons and do other things, extra LEDs. So we might look at what the references are. Good references from Seed Studio, both on the Grow Vision AI, and you can go to the shop or look at the wiki, the SenseCraft AI, and there's a couple of good modules there. There's publicly available modules, and there's also modules created by Seed Studio. And so instead of going through the complete process of making your own firmware for the AI camera, you can just use a pre-existing model. And there's also support there for the Grow 4-digit display. I'm a bit rusty with Arduino IDE, so I've got to go through and brush up. And I just do a Google search, and I'm able to brush up on my C++ programming. Okay, so stay tuned, and I'll give you a desktop demonstration. This is our Lego smart traffic lights. And while we've got Lego components, we also use the Kitronic stop bit for the traffic signals. And we've got a Grove Vision AI module with a Raspberry Pi camera, and that's looking for the number of pedestrians and counting those. So if there's no pedestrians, it will give priority to the traffic and minimum priority to pedestrians. So at the moment, it's giving the pedestrians a very short time, but if there are more pedestrians, it will increase that time. So the countdown timer for pedestrians at the moment is only 2, and most of the cycle time goes to traffic. So let's have a look at what happens when we add a group of pedestrians. So here we have our pedestrians, and we're going to let the camera see that. So the pedestrians are looking at the camera, and we'll see if that time increases. And now we've increased the time available, so the countdown timer is going at the maximum and allowing the pedestrians to cross. Let's have a look at the components that make up the system. So we've got a pedestrian countdown timer, we've got traffic signals, and they're being powered by a Xiao ESP32 computer, which is over here. So we can see the ESP32. It's going to an I2C hub, and that's driving the traffic signals with a pulse width modulation Grove module. And we've got our Grove Vision AI module just here. And it's very similar to this arrangement that we have here. So we've got the Grove module, and it's connected by a ribbon cable to a Raspberry Pi camera.